Hello everyone, welcome back. We can start part 6 of mathematics today. We can discuss exercise 1.3 because it is related with our last topic, root 3 and root 2 proof. So, root 5 you have to prove it as irrational. That is the first question. So, what we are going to assume? So, in this type of question, first we will assume that root 5 is rational. So root 5 is rational means root 5 we can write in the form of t by 2 and after cutting we know how to write a by 2. That means a and b are co-prime numbers and it does not have a common factor that we know. These are our assumptions. Based on this, I am just cross multiplying and I am writing root 5b. A is equal to root 5b. This is my equation number 1. Now I am squaring my equation 1. I will get a square is equal to 5b square. This is my equation number 2. By this, we can clearly say that a square by 5 from this equation only is equal to b square. What it means? A square by 5 is b square. That means 5 divides a square. If 5 divides a square, 5 divides a also as per our theorem 1.3. So this is the conclusion, first conclusion I obtained by my assumption. Now my second part I am going to do. When I am saying 5 divides a, that means a by 5 is a value which is c. By this, I can obtain the value of a as 5c. This is my equation number 3. Now, I am going to substitute equation number 3 in equation number 2. That is my equation number 2 is a square is 5b square. So, instead of this a, I am putting the value as 5c. So, 5c square is equal to 5b the whole square. What is this? 25c square is 5b square. Now, I am cutting this 5 and 5 and I will obtain the answer as 5c square. So 5c square is equal to b square. It means when I am taking this 5 here, I will get b square by 5 is equal to c square. So this is the case similar to this. So I can say that 5 divides b square. Therefore 5 divides b also. This is my second conclusion. So compare my first conclusion and second conclusion. 5 divides A and this is 5 divides B. It means that 5 is a common factor for A and B. A and B have a common factor that is 5. But this is against our assumption. Against our assumption. Because we already have discussed that. We already have assumed that A and B are co-prime. Co-prime means it does not have any common factor. So our assumption is wrong. So we can state that the assumption is wrong. So root 5 is not irrational, is not a rational number. It means that root 5 is an irrational number. This is the way we can prove that. Second question is, prove 3 plus 2 root 5 is irrational. So here also we can assume that 3 plus root 2 5 is rational. This is the assumption I made. So 3 plus 2 root 5 is equal to a by b. So what will be 2 root 5? 2 root 5 is equal to a by b minus 3. So we can cross multiply. So a minus 3b by b. That is 2 root 5. Therefore, root 5 is equal to a minus 3b. This 2 will come down divided by 2b. By this, you can understand that a, b, 3, 2, this negative 3, everything are what? Integers. Integers. And we know that what is the ratio of integers? When two integers are divided, we will get rational number. It means that a minus 3b by 2b is a rational number. Okay. So as it is a rational number, this rational number is equal to a number that will also be a rational number. But this is against our proof of root 5 is irrational. It is against the proof of root 5 being irrational. So we can say that our assumption is totally wrong. That is 3 plus root 2 root 5 is irrational number. It is not a rational number, it is irrational number. Next question, 1 by root 2. So here also we assume 1 by root 2 is rational. That is 1 by root 2 is equal to a by b. So when you cross multiply, what will you get? A is equal to root 2a is equal to b. That is root 2 is equal to b by a. And we know that a by b, they both are integers. That is b and a both are integers. So their integer ratio will be what? Rational. Integer by integer is a rational number. That means b by a is a rational number. Therefore, root 2 is also a rational number, but it is also against the proof that root 2 is irrational. So we cannot trust our assumption. So therefore our assumption is wrong. That is, we can say that 1 by root 2 is irrational. Okay, so 1 by root 2 is what? Irrational number is. Same way only 7 root 5. 7 root 5 is also a by b. That is root 5 is a by 7b. We know that a, b and 7 are integers. So this is rational number. So as it is rational number, we have to say that this root 5 is also rational number. It is also against our proof. So you have to write these statements like this. So root 5. So that means our assumption is wrong. What is our assumption? 7 root 5 is rational. So against our assumption means actually 7 root 5 is an irrational. And you have to put it in the box neatly. Then you will get full marks. Then the last one is same way. 6 plus root 2 also you have to prove. So I am assuming 6 plus root 2 is also a by b. So root 2 will be a by b minus 6. That is when I am cross multiplying, I will get a minus 6b by b. Here also same way, a, negative 6b, all are integers. So I have to say that this total integer by integer, this is a rational number. So as it is a rational number, this left hand side and right hand side both should be equal. So this is also a rational number. This is against our proof that root 2 is irrational. So this is our assumption is wrong. So we can say that 6 plus root 2 is irrational. So this is the proof regarding your 1.3 exercise. So thank you for watching. So please like if you are comfortable with my teaching, and please share and subscribe it if you liked it, and if you want my upcoming videos, please click the bell button nearby the subscription. So thank you very much, and next video will be related with the exercise 1.2. Thank you very much. Have a nice day. Bye.